I think it'll be able to produce a car ultimately in less than 5 seconds. Like, can you imagine a car coming off the line in less than 5 seconds? That's like, whoa.
Tesla has officially purchased a revolutionary Giga Press machine that will allow it to build the entire underbody of its affordable car, the Tesla Model Q. Here's what Elon Musk had to say about the incredible madness of the machine. Like real fast and then... I guess maybe we need to just get even bigger casting machines. Sure, why not? You know, down. Yeah, let's 50,000 tons. A massive die-casting machine the size of a house capable of producing a stunning new Tesla every 5 seconds. Sounds like science fiction. It's not! This is the game-changing version of the Giga Press. Something Elon Musk described as a giant version of a toy factory, but with jaw-dropping power that far exceeds imagination. This machine doesn't just cast one part at a time. It can mold 5 vehicle underbodies simultaneously with unbelievable precision. Tesla is the first electric vehicle manufacturer in the world to apply breakthrough gigacasting technology to mass production. While many competitors are still struggling with traditional assembly lines, Tesla has taken a giant leap by integrating revolutionary Giga Press machines into its smart manufacturing system, and it keeps improving dramatically. It all started with the 6,000-ton Giga Press used for the Model Y, which replaced over 70 separate parts with a single aluminum piece in one shot, cutting production time, lowering costs, and boosting precision amazingly. Then came the 9,000-ton Giga Press, powerful enough to form the underbody of the Cybertruck, one of the most advanced chassis in the EV world. But Tesla's ambition doesn't stop there. The upcoming 50,000-ton Giga Press is set to achieve something no previous Giga Press has ever accomplished. So why is such an enormous pressing force necessary? And how can a single machine produce 5 vehicle frames at the same time? Let's dive in and find out the stunning truth. Welcome to Auto Intel. Before we get into the cutting-edge EV manufacturing tech, let's go back to the beginning, to where the revolutionary concept of the Giga Press was born. This isn't your average machine. The Giga Press is a high-pressure die-casting machine developed by Italian company Hydra, which is now part of the LK Machinery Group. Few people know that this revolutionary idea actually began with a simple, everyday moment. Elon Musk, while holding a die-cast toy car at his desk, suddenly asked himself, why can't we do the same with real cars? What started as a seemingly wild question led Musk to envision an entirely new direction for the auto industry. Instead of assembling hundreds of stamped steel parts using welding robots, why not cast the entire car underbody as a single solid piece of aluminum? At the time, Tesla was struggling with pressure to ramp up production of the Model Y, the company's best-selling vehicle. The challenge was to speed up manufacturing while slashing costs dramatically. The Giga Press became the game-changing strategic solution.
The design of the Cybercab line, it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line. In fact, the line will move so fast that actually people can't even get close to it.
According to many industry estimates, replacing a traditional multi-art underbody structure with a single cast piece has cut production costs by 20 to 40% per vehicle frame. But the road to turning this bold idea into reality was far from smooth. Elon Musk reached out to the 6 largest die-casting machine manufacturers in the world to request the creation of a massive high-pressure casting machine. The result, 5 companies said no. They dismissed the idea as crazy, unrealistic, and far beyond the technical standards of the automotive industry at the time. In the end, only one company was willing to take the risk, Hydra. Even then, they weren't entirely confident. At first, everything was just a maybe. But after nearly a year of collaboration with Tesla, Hydra succeeded in building the world's first revolutionary Giga Press. As we mentioned earlier, Giga Press machines are now used to manufacture large vehicle components, especially the underbodies of models like the Model Y and the Cybertruck, using forces of 6,100 tons and 9,200 tons, respectively. The operating principle of the Giga Press starts with melting an aluminum alloy at extremely high temperatures in a furnace. The molten aluminum is then injected into a metal mold shaped like the component being produced. For example, a car's underbody frame. The Giga Press applies extremely high pressure to ensure the molten aluminum fills every tiny detail of the mold perfectly, leaving no defects whatsoever. Once cast, the part is evenly cooled, causing the aluminum alloy to solidify into its final shape. This process requires extreme precision. If it's too fast, air bubbles can form. If too slow, the aluminum may start to cool before the mold is fully filled. Cooling is carefully controlled through a uniform cooling system, helping the final part achieve high strength and dimensional accuracy. After cooling, a robot removes the part from the mold, trims any excess material, and sends it through a rigorous quality inspection process. It may sound complex, but in reality, the entire process happens incredibly fast. The advantages of vehicle frames cast by the Giga Press are significant. By casting a single large piece instead of welding together dozens of smaller parts, Tesla reduces overall vehicle weight, increases structural rigidity, and boosts performance, all while saving time and price. Labor on the production line. Beyond Tesla, other automakers like General Motors, Hyundai, Volvo, Zyker, and Xpeng have also invested in this cutting-edge technology. Notably, Xpeng is committed to a massive 16,000-ton Giga Press. However, Tesla remains the first and so far the only company bold enough to push the limits with a 50,000-ton Giga Press. Why does Tesla need a 50,000-ton Giga Press? Producing the Model Y's rear chassis using the 6,000-ton Giga Press has allowed Tesla to cut manufacturing costs by up to 40% by replacing around 70 separate parts with 2 larger castings and a structural battery pack. So, it's no surprise that Tesla is looking to replicate this efficiency with its upcoming affordable vehicle platform. The new car is even smaller than the Model 3, with a design that features very short front and rear quarters and virtually no trunk space, making it an ideal candidate to test the revolutionary idea of casting a decorous single-piece rear chassis. But no matter how small the car is, the 6,000-ton press used for the Model Y isn't powerful enough to cast the entire chassis at once, as it can currently only cast the rear chassis. So Tesla used a larger Giga casting machine to produce this game-changing low-cost car called the Model Q. Not only does it allow for the entire chassis to be produced in one casting, but the Giga Press can also cast 5 chassis of this model in one revolutionary casting. The design of the Cybercab line, it doesn't look like a normal car manufacturing line. It looks like a really high-speed consumer electronics line.
And that's actually kind of how they do it in like small volume castings. They'll like have a casting block that'll make like 100 Matchbox cars at a time. Maybe we just make that real big. Yeah, I mean we have the Cathedral of Casting back there.
It's in fact, the line will move so fast that actually people can't even get close to it. When Elon Musk first mentioned the 50,000-ton Giga Press, the first question we asked wasn't, is it even possible? But rather, how massive is it going to be? Where would such a massive machine even be placed? How long would it take to install? And how could it possibly cast 5 entire underbodies at once? Well, this is no ordinary machine. According to Elon Musk, the new production line using this machine will operate at a speed so fast that humans won't even be able to get near it. The entire process from pouring molten metal to high-pressure casting, mold cooling, and part removal will be handled entirely by robots in advanced automation. No workers standing nearby to inspect, no one manually adjusting parts. Everything will be synchronized in a fully closed-loop system where each press cycle takes only about 5 seconds. In other words, within just a few blinks of an eye, a complete one-piece EV frame will be finished and ready to move on to assembly. We're halfway through this incredible journey, and if you're loving this content as much as we are, smash that subscribe button right now. We're so close to 1,000 subscribers, and every single one of you makes this dream possible. You can imagine that with a 50,000-ton Giga Press, it could easily be as large as a 3- or 4-story building laid on its side. Tesla may need to construct a dedicated facility just to house it, possibly with a specially reinforced concrete foundation several meters deep to support the immense weight. Compared to the existing machines like the 6,000-ton and 9,000-ton Giga Presses, this new machine delivers roughly 8, 3 times and 5 times more pressing force respectively. While the size, clamping force, and number of molds differ, the operating mechanism of the 50,000-ton Giga Press isn't fundamentally different from the 6,000 or 9,000-ton models. It all still starts with material preparation. Tesla melts down new aluminum ingots along with leftover aluminum from previous castings in a furnace heated to around 850 Celsius or 1,562 Fahrenheit. Then any surface impurities are removed before the molten metal is transferred through heated pipes into a sealed holding furnace, maintaining a temperature between 1,382 Fahrenheit to MT, 1,562 Fahrenheit. From what we know, the Giga Press uses a dual furnace system to process the aluminum alloy. One furnace acts as the melting furnace, powered by natural gas and operating in around 1,562 Fahrenheit. The other serves as a holding furnace, electrically heated and maintaining a temperature between 1,382 Fahrenheit and 1,562 Fahrenheit. As previously mentioned, inside the holding furnace where the molten aluminum is stored, the empty space is filled with nitrogen gas. This is no coincidence. Nitrogen acts as an invisible protective layer, preventing the aluminum from coming into contact with outside air and thus avoiding oxidation. At the same time, it helps maintain a stable temperature, keeping the metal in a ready-to-cast state. But nitrogen alone isn't enough to achieve optimal casting quality. Tesla also uses argon gas in combination with a rotary degassing unit, a device that stirs the molten alloy and drives gas bubbles and impurities to the surface. After that, a specialized silicon carbide filter removes particles larger than 25 microns, ensuring the alloy is clean and uniform before it enters the mold. This is the material refinement stage, an extremely important step to ensure the quality of the final cast product. This is the material refinement stage, a critical step in ensuring the quality of the final cast product. Once the material is ready, the next step is mold preparation. And the Giga Press handles this with near-perfect precision. Before each casting cycle, a specialized robot sprays about 35 ml of soybean oil in a thin, even layer across the mold surface. It's a bit like non-stick coating in cooking. This helps the cast parts release cleanly from the mold without warping or surface defects. Immediately afterward, the system creates a vacuum inside the mold cavity, removing any remaining air to ensure the molten aluminum fills the mold completely without trapped gas or bubbles. Once everything is perfectly aligned, the molten aluminum is transferred from the holding furnace into the Giga Press's injection chamber. There, a high-speed piston injects the alloy into the mold at extremely high pressure. To ensure smooth operation, the piston itself is lubricated with about 8 ml of oil before each injection. Everything happens in just a matter of seconds, but every detail plays a crucial role in producing a one-piece EV frame with micrometer-level precision. Within a single casting machine, we could do like 5 at a time or something, you know? Trying to think like how do you scale castings because you got liquid metal, metal's gotta cool. And you've got automate, getting all the bits and pieces off the casting so it's usable. When the molten aluminum is injected into the mold, solidification doesn't happen instantly. The alloy needs to remain inside the mold for a few seconds to begin the crystallization process. Once the material is solid enough, the entire underbody frame is ejected from the mold at a temperature of around 400 Celsius or 752 Fahrenheit. Still extremely hot compared to ambient conditions. Immediately afterward, the cast part is transferred to a cooling bath where the temperature rapidly drops to around 50 Celsius or 122 Fahrenheit in just a few dozen seconds. Rapid cooling isn't just about lowering the temperature. It also serves an important technical purpose, improving the alloy's crystal structure, eliminating defects formed during solidification, and enhancing the mechanical strength of the entire underbody frame. So, we got to jam the liquid metal in, cool it down real fast, like real fast. Meanwhile, the mold after releasing the cast part is cooled down to around 185 Celsius or 365 Fahrenheit, a temperature low enough to stabilize heat levels without purdy, affecting the next casting cycle. A specialized robotic system then thoroughly cleans the mold surface, removing any leftover material residue and excess lubricant. Thanks to the speed and precision of the entire system, a new casting cycle can begin just 1 to 2 minutes after the previous one ends. Any excess metal, such as flash, rudders, or leftover sprues, is automatically trimmed and recycled back into the melting furnace for future cycles, ensuring virtually zero material waste. To make sure every product meets strict quality standards, an industrial X-ray imaging system is deployed directly on site. Each vehicle frame is scanned to detect microscopic defects such as gas porosity or internal cracks that can't be seen with the naked eye.
So we got to jam the liquid metal in, cool it down real fast, like real fast.
This is a critical step in ensuring structural integrity, especially important since this cast frame serves as the primary load-bearing foundation of the entire vehicle. And finally, to withstand the immense pressure of injecting molten alloy in high speed, the Giga Press must maintain an extremely powerful clamping force to keep the mold tightly sealed, preventing cracks, warping, or leaks. With the 50,000-ton Giga Press, this clamping force ranks among the strongest ever used in the automotive industry. According to Elon Musk, achieving the incredible speed and precision of the 50,000-ton Giga Press required Tesla to develop a series of groundbreaking innovations never before seen in the auto industry. First is an ultra-fast cooling system custom-designed to rapidly cool massive cast components in record time without compromising the metal's structural integrity. Second is an intelligent mold release mechanism that allows parts to separate from the mold smoothly and precisely with no manual intervention required. But the biggest breakthrough lies in the AI-integrated automated quality inspection system. From analyzing X-ray images to evaluating real-time data from thermal and pressure sensors, this system can detect potential flaws with high accuracy, completely eliminating the need for human visual barrel checks. This represents a major leap forward compared to previous generations of gigapresses such as those used for the Model Y and Cybertruck, which were already highly advanced but still hadn't reached the deep intelligent level of automation seen in the 50,000-ton Giga Press. More importantly, the fusion of robotics, artificial intelligence, and precision engineering has brought Tesla closer to a production model that closely resembles the electronics industry. Ultra-high-speed, hyper-streamlined processes, factory floor space optimized down to the square meter, and near-zero variation between repeated products. As we mentioned earlier, Tesla needs to replicate the efficiency of the Giga Press for the Model Q, and this compact hatchback is seen as the most ideal candidate for fully casting its underbody using the Pratsa 50,000-ton Giga Press. The reason goes beyond just aiming for massive production volumes. It lies in the design philosophy and industrial strategy behind this vehicle. First and foremost, the Model Q is positioned as a global, affordable EV, targeting the mass market with an estimated production volume of millions of units per year. At such a massive scale, streamlining the production line becomes a matter of survival. Casting the entire underbody in a single press cycle drastically shortens production time, reduces labor costs, minimizes the number of welding robots needed, and optimizes factory floor space, perfectly aligning with Elon Musk's matchbox manufacturing philosophy. And that's kind of how they do it in small volume castings. They'll do have a casting block that'll make 100 matchbox cars at a time. We just make that real big. Yeah. I mean, we have the cathedral casting back there. The Model Q features a compact and simple design without the complex curves or multi-layered structures seen in the Model Y or Model 3. This structure is ideal for casting the entire underbody as a single piece in a short amount of time, what Musk described as just 5 seconds. I think it'll be able to produce a car ultimately in less than 5 seconds. Can you imagine a car coming off the line in less than 5 seconds? That's whoa. It may sound like science fiction, but in reality, with an optimized structure like the Model Q, Tesla can completely press out the entire chassis in just one pressing cycle, lasting less than 5 seconds, not counting the next assembly steps that are fully automated by AI robots, aligned so fast that humans cannot get close. If this becomes a reality, Tesla is not only speeding up production, it is redefining the limits of global industrial manufacturing capabilities. Please share your opinion in the comments section below this video. Thanks for watching our video. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to subscribe to Auto Intel and turn on notifications so you never miss our latest videos. We're almost at 1,000 subscribers, and your support is what makes this incredible journey possible. We appreciate your support and look forward to seeing you in the next video. Goodbye.
This audio was created with Podcastle.ai